Systematic electrical diagnosis in a port fuel-injected engine is essential when performing any repair. For instance, this vehicle has been presented with a no-start complaint. Using the oscilloscope, I can quickly determine that compression pressure is even. I can also use the scope to determine if the fault is fuel or spark related. Once I've established the fault may be fuel related, I need to connect the test gauge and check for flow and pressure. As you can see, under crank conditions, the vehicle has no flow or fuel pressure. We need to determine if the problem could be a restricted fuel line or pump circuit fault. This can be done by simply listening at the fuel tank. You may need to use a scan tool to activate the pump. If you can hear the fuel pump operating, then the fault may be a restricted fuel line, dislodged component, or an empty fuel tank. I can't hear any pump operation, so I'll need to progress to the fuel pump circuit and continue my diagnosis from there. There are several ways to test a vehicle's fuel pump electrical circuit. The selected way will depend on the type of fuel delivery system the vehicle has. The easiest and fastest way to test a fuel pump circuit is with an amp meter. Remove the fuel pump fuse and insert the meter. Enable the fuel pump circuit by either cranking the engine, using a scan tool, or bridging the fuel pump relay. Be sure to inspect the fuse for opens. A blown fuse would indicate excess current draw in the circuit. The current draw of most fuel pumps will be between 4 and 8 amps. A 0 amp draw indicates an open in the circuit. A low current draw could indicate a pressure loss. This could have a mechanical or electrical cause. Again, don't forget to check the fuel level within the tank. A higher than normal current draw may indicate a restricted delivery, return line, or a pump motor fault. Another way to test a fuel pump circuit is to use an oscilloscope with an amps clamp. This can be attached to a fuse extension or clamped directly around the fuel pump supply cable. Enable the fuel pump circuit by either cranking the engine, using a scan tool, or bridging the fuel pump relay to activate the fuel pump. When looking at the display, we can see a correctly operating fuel pump will draw around 5 amps. Each hump in the trace relates to each sector of the commutator. Any repeated irregularities or disturbance in the trace will signify a fault. A higher than normal current value on the trace will point to a restricted delivery or return line. And again, a lower than normal current draw indicates the pump motor is spinning but with minimal load. This could be an impeller failure, a fault in the pressure regulator, or even a lack of fuel in the tank. If there was no current flow, we would need to check if there was continuity through the fuel pump circuit before proceeding. With the fuel pump fuse removed, set the meter to ohms and connect one lead to the supply terminal. Connect the other lead to a known ground point. If the meter displays continuity, then there may be an open in the relay side of the fuse. If the meter shows infinite, there may be an open or high resistance in the fuel pump supply, or ground circuit. We can use a multimeter set on volts to check the rest of the pump circuit. Disconnect the fuel pump connector and connect the meter across the harness supply and ground terminals. Don't use an external ground for this test, as we want to check both high and low sides of the circuit. Enable the fuel pump circuit by either cranking the engine, using a scan tool, or jumping the fuel pump relay. Battery voltage here indicates a functioning circuit to the pump. A lack of voltage will require the supply and ground circuit to be tested. Using a multimeter set on volts, connect between battery negative and the supply side terminal. Confirm there is battery voltage. No voltage reading would suggest an open in the supply circuit. Confirm the fuel pump supply fuse is OK. Test for correct voltage and correct terminal tension at the fuse terminals. If correct voltage cannot be found, inspect the supply relay for correct operation. If correct voltage was found at the fuse terminals, it will be necessary to locate any other circuit connectors and test. A correct voltage on one side of the connector with no voltage on the other indicates an open within the connector. Check for corrosion and correct terminal tension. If correct voltage is found at one connector and not at the next connector, then the open is between the two connectors. A short to ground in the supply circuit will cause the fuse to open and the pump to stop operating. Remove the fuse and insert the multimeter across the fuse holder terminals. Disconnect the fuel pump connector. Enable the fuel pump circuit by either cranking the engine, using a scan tool, or jumping the fuel pump relay. Any voltage reading observed indicates a short to ground in the circuit. Locate and disconnect the next connector in line while observing the meter. If the meter now displays 0 volts, then the short is in the disconnected section of harness. If the meter still displays voltage, continue unplugging connectors until a change in the meter is observed. This will isolate the short to that section of harness. Excess resistance in either circuit may cause a lack of flow or pressure. With the meter connected between the supply and ground terminals of the fuel pump connector and the scan tool commanding the pump circuit active, a meter reading of significantly less than battery voltage indicates excess resistance. We need to isolate the excess resistance to the supply or ground circuit. Start by moving the ground terminal meter lead from the harness connector to a known chassis ground. If the meter now displays battery voltage, then the excess resistance is in the ground circuit. If the meter displays less than battery voltage, the excess resistance is in the supply circuit. Repeat this test at any other connector in the harness to isolate the fault. An open in the ground circuit will result in no current flow through the pump. With the meter leads connected between the fuel pump supply terminal and the ground path, and the fuel pump circuit enabled, battery voltage should be displayed. If there is no reading displayed, move the meter lead to a known ground and repeat the test. If battery voltage is now evident, the open is in the harness between the fuel pump connector and the chassis ground. Always check any connectors in the circuit for corrosion and terminal tension. If the supply and ground circuits test OK, then the only possible fault is the fuel pump. Some of the tests we've just performed may be carried out on the low pressure side of GDI and CRDI systems. Again, try to perform 2 separate tests to confirm a diagnosis on a fuel system. Thanks for watching. See you next time.